This is the CNC Router Tips podcast. Hi, everyone. This is Bill Griggs, and welcome to another episode of the CNC Router Tips podcast. I'm so glad that you took the time today to come and listen to us. And in this case, it's a special episode because we're trying a video version of this as well for the first time. So this is going to be fun, folks. I have been experiencing some great growth inside of the hashtag CNC Router Tips group on Facebook over the last month because we've been doing more of this, more podcast episodes, more live broadcasts inside of the show. And as a result of that, I'm meeting some fantastic people who have some interesting things to share with you about CNC and how to make your workflow better, faster, and more reliable. And to that end, today, I'm going to be talking with a special guest, and this is Alex Palm from Allstar CNC.com. Now, Alex is one of the first guests for this second season, and I hope that you'll make him feel welcome and that you'll find the information that he's got to share with us to be helpful. So, hello, Alex. How are you today?
Hello, Bill. I'm doing quite well. Thank you.
Now, where is Allstar CNC located?
So we're located in a lovely little historical mining town called Grass Valley. And we're also right next to a little town called Nevada City. We're kind of isolated up here in the mountains right outside of Lake Tahoe area in California. And I guess our noteworthy historical importance is this is one of the epicenters where gold was discovered in California. So we're nestled away here. It's a lovely little community and lots of really cool California history right in our backyard.
Oh, that's fantastic. Now, Alex, your specialty and the thing that is of interest to our listeners is that you guys make vacuum tables more useful by supplying some things that make that happen. Tell us about that a little bit.
Yeah, that's right, Bill. So all that we do here at Allstar CNC Products is focus on parts holding on vacuum tables for CNC routers. It's our core competency. We do nothing else. All of the products, which I'll get into in a moment here, are made in-house. I'm not sure if you can hear in the background, but we have stamps going in our background. We've got machinery that's cutting the material. And ultimately, what we focus on here is education followed by the products to help support our customers for better work holding. At the end of the day, we're very, very consultative. We try to educate our customers of the science and the physics that we employ on a vacuum table. And traditionally, with CNC routers that use vacuum tables for parts holding, the traditional, quote unquote, the traditional techniques would be downdrafting, where you're moving a large volume of air through the porous medium of typically an MDF. And with that typical technique, with downdrafting, there are some inherent flaws with that. We'll get into a few more details through the podcast here, the technical aspect, but the natural detriment to downdrafting is, especially if you're running sheet goods in a nested program, that the more that you cut, and this will resonate with all of your listeners here, that the more that you're cutting, the harder it is to hold parts. And the smaller the part, the greater the challenge. And the reason for this, of course, is that air is a fluid, and it's always going to flow to the path of least resistance. And so when we put a sheet on our table and we've nested our project and we've laid out our parts and we hit go on the machine, at that time and only that time, the vacuum gauge will register at its peak value during that project. And the more that we're cutting, that gauge is going to decrease and decrease and decrease over time. And again, that's because air is fluid. Well, when I look at a vacuum gauge on a CNC vacuum table, and I look at that value, for me, that doesn't represent true vacuum on a part itself. What that means to me is actually resistance to the vacuum system. So if we think about this again, that when that sheet is there, you're damming that airflow, you're damming the vacuum system, creating that resistance. Therefore, the more that we're cutting, we're developing less resistance, and the air flows through all of those pathways that we're just starting to cut into. And so that is an inherent detriment with trying to hold parts using downdrafting.
So if I've got this correct, when people start putting lots of small parts on a vacuum table platform, they have difficulty as soon as they start cutting out those smaller parts with holding those parts down to the table, because every time they make a cut around those many parts, they're losing some of the vacuum force in that local area.
Yeah, that's absolutely right. And so what people now have resorted to do is techniques to bypass this, but this slows down the manufacturing process or the processing times. So many people are onion skinning, multiple passes, or tabbing their parts so they stay in place. And people don't know what they don't know, so many of these operators have just thought that that's the way that we have to do it. And my mantra is, don't make do, make better. There's always ways that we can do that. And that's what we do here at Allstar CNC. So we employ a completely different science and physics around parts holding, known as vacuum clamping, true vacuum clamping.
Let's pause for a minute before we get into more technical details, and let's talk a little bit more about you and about the company. And I'm hearing the things that you're saying about the physics of vacuum and how it's formed and everything. How did you come to this knowledge? What's your background? What were the things that you were doing prior to this?
Sure. So my background is not actually in CNC manufacturing. I have a very technical background, going back from the origins of my career, mostly in laser physics and microwave physics. So I'm a geek. I'm a science-minded guy altogether, but also with the business mind in place to really provide solutions ultimately to our customers. My viewpoint really on a good, successful business is integral around the solutions that we provide to our customers. So we're not selling stuff, right? We are really providing relief to pain points. We're providing solutions to problems. And those are all any of the products or the knowledge we have are just vehicles to provide those solutions. And so I came to Allstar really not that long ago. Allstar has its origins back more than 2 decades ago. We are a spinoff from an adhesives company, Allstar Adhesives, out of the Northeast. And my colleague and good friend Mike Murphy is the founder of Allstar CNC Products. And so we spun out 2017-ish or so. So we're about 5 or 6 years of our core competency just on the CNC router world.
And of that 6 years, how many have you been working with Allstar CNC?
Less than a year. I came in November of last year, and Mike and I have been talking for quite some time. He had asked me to come in and help him lead the company and help grow the company, bring it to its next level. And I'm happy to be here. It's a great great company with great culture. And we are a small company. We're growing quickly, but we still have those great roots into our community and the family and everything that embodies that.
So I'm guessing that Grass Valley is not a hotbed of laser research activity. Were you somewhere else prior to this?
Yeah, I was. I was doing the San Francisco Bay Area rat race for quite some time. It was interesting, dynamic, but also exhausting and very vapid. You tend to uh, well, live in anonymity in the certain capacities. Traffic, I usually call it the Great Migration twice a day.
Mhm.
And the big city life. It was great when you were younger and you wanted to trailblaze and work, crazy hours. But as I think we all can resonate with this, and depending on what stage in life that you are in, quality of life is everything, and work is always going to be there. So I never even heard about Grass Valley or Nevada City. And true story that 6 days after I came to this area for my very first time to visit, the proverbial heavens parted, rays of light came down, angels were saying, "Hey, you need to live here." So I took an industrial electrical engineering company that I was a partner in, and we moved it here to this little town. We brought as many employees as we could, and we established new roots here. And then a couple of years ago, I spun out of that and sold my interest, and then was looking for the next thing. And yeah, you're right. Not a lot of laser physics, microwave stuff going on out here, and I was trying to figure out what to do next. And Mike got in touch with me through the network in our area, and understood my acumen in both business and technical. And we he intrigued me with what the company was trying to do, and the potential that the company has. And well, I guess the rest is history so far.
Mhm. It's funny. One of my best friends from high school was an engineer for an electronics engineering company, and they used to make LTDRs for light time domain photoreflectometers, I think they were called, or something crazy
Yep.
like that.
Yep.
It was a tool that they used when they were first getting started with the oh I I love it when you can remember LTDRs, but you can't remember fiber optics in the moment you're trying to say it. But yeah, it was, and they used um, lasers in part of that. And so I'm curious if that was a similar thing to the type of work you were doing back then in Silicon Valley.
Yeah, it is in fact. So you talk about time domain and also with lasers, that we had developed quite a bit of elaborate timing schemes and timing systems for lasers. And lasers are ubiquitous in science, but when we look at time domains, we know that light travels at a finite distance, 186,000 miles per second, right? So everything from LiDAR with mapping or time domains or range finding, et cetera, just like even when you have your police on the freeway, right? They're
Hmm.
using the speed guns. If you get nailed with a laser gun, you're toast because it's not like radar guns. But so light travels at a finite distance. You use a specific wavelength. You put out a pulse. You put out an emitter. You wait for the return from the receiver. And that period of time, be it microseconds, milliseconds, or even nanoseconds, are going to dictate how fast you're moving, where you're traveling, the rate of speed, and whatnot.
Hmm.
Yeah, lasers are used in time domain applications ever increasingly, right? And I talked about getting out of the San Francisco Bay Area, visiting my daughter recently in San Francisco. I've only been gone for 5 years, but I felt like I was visiting Oz because there are driverless taxis all over the city, and it's bizarre to see people hanging out in the back, and there's a no driver in the front, and you're like, wow, I'm living in the future right now. But that's all based on time domains using lasers. So they're using LiDAR, laser mapping, or laser radar. And so yeah, I work tons in that. But yeah, fascinating stuff, right?
Yeah, yeah, it's obscure, but I enjoy
Me too.
talking about that sort of thing. Um, one one aspect of living in San Francisco Bay Area, um, other than just the huge crush of people trying to get or trying to get where they're going there, is that you lose a little bit of your individuality when you're living in a huge city, and a lot of folks find that uh, hard to deal with. So when I hear that you moved from there to Grass Valley with totally different dynamic, a small town feel. I wonder what's a day like? What's the difference in a day from one place to the next?
It couldn't be more different, frankly. It is everything that I enjoy. I love people. Everybody's got a story. And incidentally, the older that we are, the richer the stories. And
Mhm.
coming out of the Bay Area, you're just sort of an ant in the hill moving around. And there's even probably less community than there is in an anthill, and here people it's all about the community, and we all look out for one another. So yeah, typical day around here is you don't you if you go somewhere and you don't see somebody that and there's it's hugs before handshakes. It feels almost odd. And when you do go to restaurant or dinner downtown, you're really expecting to run into friends and people and you love. And community is everything, and it's I'll never go back.
When I first heard about Allstar CNC from one of the members of my Facebook group, the hashtag CNC Router Tips group, and uh, Kelly Boatwright was just in the process of updating his router table. He had a router table that came originally from a Chinese company. I think it was Blue Elephant. And over time, he'd stripped out the control systems and he'd added work hold down with T-tracks and things like that. But then he decided that he wanted to go with vacuum. And he got it set up for a vacuum table with multiple zones, his table. But he wasn't satisfied with the way his parts were being held down. And so a few weeks ago, even it was a very short time ago, he mentioned that he was going to start using some of your product on his machine. And I asked him just last Wednesday in one of the live chats whether it had been a good experience for him, and he just raved about it. So if you would like to look for the live chat from the Wednesday the 2nd of August, it is inside the CNC Router Tips group on Facebook, and you can just watch that, but hear his actual words about it. But you have a variety of products. Tell me what he used, if you know.
I do. Yeah, he used a combination of two products. One is an integral gasket, and very important to the vacuum system. It's called grid gasket, and that essentially is, ironically, it's one of the most important parts to the vacuum system, but it's the most overlooked part. And it's simply a basic gasket that's going to sit in the plenum in the grid system underneath the spoil board, and it's going to sit within the zones there and seal up underneath the spoil board. So no matter if you're downdrafting, which we talked about before, or you're employing vacuum clamping techniques, which we'll get into, regardless, that's always a very, very important gasket to use. Now, I will pause or preface for a moment that with Allstar CNC, all of our products, with the exception of some tooling and some peripheral complementary products, our core product line is gaskets, gasketing materials, different types of gasket and the mediums, the different products, but they're all with the basic principle of sealing the system and then sealing to your part. And again, we'll get into the details a little later, but so with your vacuum system, the grid gasket is sort of the first base in trying to win a score, I guess. And unfortunately, so many people don't pay attention to it. They don't replace it. We did a little marketing campaign just a couple months ago, a little tongue-in-cheek marketing campaign, but May was Grid Gasket Awareness Month. And every other day we were posting the social media out there that, give your vacuum table the love that it deserves. So The grid gasket it's a cheap investment. It's tens of dollars essentially to get that right gasket underneath there. And when we talk to customers, we ask them, that's the first thing is, when's the last time you changed that grid gasket? And too many times the response is, well, what's that? Or I've never
Mhm.
changed it, or it came with my machine, or I use silicone, God forbid, or other products or materials to be able to seal that. Now, I will say that not all gasket material is created equal. We talked to lots of different people, and some will even go to the hardware store and get window, open
Mhm.
cell foam and whatnot. It's not appropriate. So we use the right orientation, meaning a square gasket belongs in a square channel. Too many people, even all the way up the food chain to the CNC manufacturers, are providing round cord within those square channels. And that's
Mhm.
not an appropriate geometry, if you will, because obvious reasons, right? So we've got surface area that's not optimal for great sealing qualities, and further to which, um, round cord is an extruded material, so it's formed hot and it's pushed out of a press. So think about when we were kids playing with our Play-Doh sets and we got to push that out. Well, you're going to find small imperfections in the surface area, little bubbles, and the deviance or the variation between the size is going to vary. It's going to have a greater variance. So
Mhm.
with that in mind, everything, as I mentioned, everything is produced in-house. So we precision cut all of the square gasket. We also carry round for round channels, but all of our square gasket is cut to the very, very specific size for each table. So we have cheat sheets or guides, what certain manufacturers have for their table, but those change over time. And so we'll work with our clients. They'll measure the width and the depth of the channel using a pair of calipers just to verify that. And then we make sure we get an absolute precision gasket to fit in there. And that's step one.
Just back up for a second. You said that you custom make this for each table brand.
That's right.
So someone is getting a custom made gasket that's perfect for their table when they order.
That's right. So
Huh,
we
I
carry a
wasn't
lot
aware
of,
of that. Yeah.
yes, that's right. We carry a lot of stock sizes for all the various channel sizes that are out there. Now, if there is a size that's odd, or we need something custom, we will absolutely cut to fit. We'll laminate products to fit in there. But the point being is that no matter the channel size, we're always going to cut or custom cut or cut specific to that channel size. So
I'm gonna
every time there's a perfect fit.
Yeah, I'm gonna share the screen for a second. I went to look. Now, this is what many people think of when they I hope that you're able to see this
Mhm.
picture. But this is what
That's right.
many people think of when, they're looking at a vacuum table on their router. And, uh, you would you've been talking about a gasket for the individual um, channels between these squares all over the table. Am I correct in that assumption?
Yeah, you are. That's an interesting orientation. That almost looks as though it was produced kind of a custom or one-off, or perhaps
Hmm.
somebody did that. But the premise all remains the same. So what we're looking at here is multiple zones in front of us here. We see two zones, and then the further back you've got some other zones, and you've got maybe some spoil board that's covered up. Each zone has its dedicated vacuum port, and the grid that's there, that's called the grid, where you've got the little islands or the squares. That's to allow the spoil board to sit on top, where it's not going to bow. Those islands, those squares are there as a support function for the spoil board. And the grid, all of those channels allow the vacuum to permeate underneath the spoil board itself.
Hmm.
So we need to seal that zone underneath the spoil board, so the outside perimeter of each zone, the outside perimeter will have a square gasket that we
Hmm.
will embed in there. And there are certain rules of thumb, for lack of better terms, in that aside from having the right width, the depth is quite important. And what we have found through trial and error is that having your gasket sit proud only 1/16 of an inch above the channel provides the best sealing properties. Too much, and you're going to get kind of a mushroom effect,
Mhm.
where you can get some pinching, and then of course too little, and you're not going to get that rebound or the sealing properties appropriately.
Yeah, I think I'm pretty sure that that table was custom made by the owner of the table. In other words, he's um, bolted down some MDF and then went ahead and he cut this pattern and then built, on top of it, he would lay a spoil board or whatever piece he was doing. In a lot of cases, I see guys try to lay their finished material or the material for their workpiece right on top of it without a spoil board in between
Yeah.
too. So yeah.
Now, one point that you just mentioned here, or something I'll bring up, is that we consult a lot with everything from the OEMs when they're designing their new table, and any kind of guidance we can provide them, along with the DIYers, the people that don't have vacuum tables that are building their own. One thing that's important for everybody to sort of understand and realize generally or ubiquitously is that if you're building a vacuum plenum, you're going to want to build it out of something that's non-porous. So people do it out of MDF, but then you got to seal it, you got to paint it, you got to put some lacquer on it. It's not ideal. So if you're going to do it well, do it right, make the investment into getting something that's non-porous. Typically, we see HDPE or phenolic. People even use aluminum if they want to get really fancy. But at the end of the
Mhm.
day, you want to, because we're trying to hold vacuum in there, we don't want to have any leak. Leak is going to be the antithesis there of holding that vacuum.
Yeah. I worked as a CNC operator for a company a few years ago, and they had an Ohmsrud um, commercial machine with aluminum vacuum tables on it, vacuum grid, and that was a very nice machine. It was a little bit difficult at times to ensure a good vacuum with uh, raw material. We were doing a lot of plywoods and MDF, and sometimes it would take two or three guys standing around the table pushing down on the edges of this board
Mhm.
in order to give the vacuum a chance to seal,
Yeah.
so that it would, once it got a hold of it, it sucked it down and everything became flat. Um, from what I understand with talking with Tally, he doesn't have that issue now with what he's done using your product. I also have some photographs here of part of his build process that he was doing as he was converting to your gasket. Um, um, maybe we'll share those and talk about it. But I do not know uh, what material he started with. I don't know if he started with an MDF or went to HDPE or phenolic or whatever. But maybe you can tell the photographs. I don't know.
Oh, I could probably see from the photographs. He's sent us some videos and has posted things online. I would be able to. I just don't recall off the top of my head. That's phenolic.
So
Yeah,
he had
yeah.
phenolic down.
He retained the T tracks. So here's another good point too, Bill, is that if you look sort of in between these zones, his zones are unique by virtue that they're these really long zones. He's got 3 vacuum ports, what it looks like per
Mhm.
zone. Now, if you look in between the zones, you've got the T track, and then you've got material between those zones there. Now, this is an area when we consult with manufacturers and they're going to design a table. Too many manufacturers want to be everything to everybody. So if you're going to use a vacuum bed, great, but let's focus on the vacuum, and we recommend eliminating the T tracks altogether, or do not segregate your zones. So if you look in between those zones there, between the T track and then the material between the T track, where you've got those segregated areas between zones, if you can
Mhm.
imagine a spoil board on top of there, that's going to be a desert or no man's land when it comes to parts holding. So that becomes a liability. If you have small parts that are nested on that T track there on a sheet good, you're going to have difficulty holding those parts. Now, there are ways that we can get around that, But typically what we suggest when making your own bed is have an open grid. And
Mhm.
the grid gasket, which you're seeing there on the outside perimeter of those channels, that acts as your dams, and it gives you ultimate flexibility of the orientation of your zones, how you want to configure them. And it's really the best for vacuum parts holding, having an open grid and using the grid gasket to segregate those zones out.
Now, would you be able to have a custom made gasket that could fit down the slots of his T-track um, and still maintain them? Or I know that it would
Yes.
be a better solution if you were to remove them, but
Yeah, right. So you're gonna when you puts the board on there, you are gonna get some leak through that T-track because MDF is a porous medium. So just through the fibers of the board itself, as the vacuum is running through it, you're gonna get some leak. Um, we could custom cut a gasket in there. I would probably, if I were to go back to Tally, I would um, I would remove the T-track and put a large thick gasket in there.
I'm sorry, wrong,
That's
wrong
the other
email.
product he's using.
Yeah, yeah. I think I think this is his old gasket material. I'm not certain.
Looks old. It
Yeah.
does.
Um, this is I should have probably prepared ahead of time. Now, here is the new stuff. I know that these are square in cross section versus what he had prior. We can see the gasket around the edges.
That's right. Here's another good point too, and I've counseled him about this because I think even one of these pictures, if you'll see there on the either the bottom of the picture, bottom or top of that zone where he's sort of pigtailed out that gasket. I would counsel against that. The best thing to do is actually to butt the gasket, butt it together. You cut it just slightly long so it compresses down and holds a
Mhm.
tight seal right there. That can be a compromise to the sealing. So he's actually changed that. And you know, it's all a learning process.
Yeah, so right in this area we're
That's
talking
right.
about on the
Yep,
screen.
that's
Uh,
right. Yeah,
yeah.
you can see because where it turns, where it makes that 90, you've got a small edge along that radius. So you've got just a little bit of material trying to hold that vacuum, right? So if you butt it, you've got the best surface area and you've got a little surface tension, or you got tension on those surface areas where those gaskets butt together.
Mhm. And this is, this is kind of in the process of as he was converting over and starting to implement your system. And I know that this is the gasket that he was using. In his case, it's a square gasket cross section.
That's right.
See it. And I know that he also used this product afterwards, but we'll get to that, I hope, and talk about what
Yep,
uh,
definitely.
that does. So anyway, I interrupted you. I just thought folks could use a visual of some of the things that we're talking about.
Right. Well, you know, these are great examples for Bill. And you know, so ultimately, no matter who the client is, no matter what type of work that they're into, either large production, repeatable parts, or custom one-off projects, cabinetry, sign makers, etc. We always start with the grid gasket, and we tell our clients that, hey, this needs to be changed on a regular basis, along with your maintenance. So every 400 to 500 production hours, change out your grid gasket. It's always a good time whenever you're going to change out that spoil board, or keep your parts counter going. Take note of it and reset it when you do that. And the reason being, of course, is that every time we're turning on that vacuum system, it's slamming down and holding that spoil board, going up and down, up and down. Those are compressive qualities. And I mentioned before that gasket is not created equal. Well, our material is only used for sealing on a CNC router underneath that spoil board, and other areas, of course. But we use a very specially designed microcell PVC material that has the proper compressive qualities to it and the sealing properties too. So air is not going to leak through that. So we always start there, use the right orientation, use the right size, use the right manufacturer. There's nobody like Allstar in the entire industry. We are the experts in this field, so we proudly say you should buy buying it from us, and it's low cost. So once we've established a good seal underneath the spoil board, then we focus on holding parts on top of the spoil board. And that's where the difference really comes into play between downdrafting and vacuum clamping.
So the product that we saw the picture of with all the holes in it, kind of like a pegboard
Yep.
configuration, that is for the top of the spoil board.
That's right. So for me to talk about what that is, I'm going to have to talk a little bit more about what vacuum clamping is. Now, what we always focus on here at Allstar CNC is the I'm not going to harp on the science or the physics per se, but it is a different there is a different science between downdrafting and vacuum clamping. Everything that we do, not a little bit, but everything that we do is focusing on creating negative air pressure underneath the part that we're cutting. And we call that a negative air pressure differential. And so what we're doing is we're using gasketing material to create little vacuum chambers or pockets underneath your part. And your vacuum system is evacuating a little bit of air in that chamber or that pocket. So I would wager to guess that every single one of your podcast listeners have been on an airplane at one point or another. People may take for granted how airplanes fly. Well, airplanes fly because of you're developing negative air pressure underneath the plane that gives it lift. So we're doing the same thing, but we're doing the opposite of. We're actually using negative air pressure underneath the part to use atmospheric pressure on top to push that part down. So if we go back to my original comment about downdrafting and how inefficient it is, but when we employ vacuum clamping, it has very little to do about the volume of air that we're pulling through the system. It's not about CFM. It has much more to do everything with how strong of a vacuum pull we can establish with the vacuum system. Typically, this is measured in various units of measure. Inches of mercury is a common unit of measure. So the stronger the vacuum pull, the greater the hold that we can have. But you can imagine if you have a very small pocket, a chamber, all we're trying to move is micrograms worth of air underneath that, right? So negative air underneath, that pushes it on top. So what's very, very helpful here, there are so many benefits that we have found for our customers, but one of which is that we have saved countless customers from buying more pumps, larger pumps. And unfortunately, there's this knee jerk in the industry. And again, sometimes it goes all the way up to the CNC manufacturers, is that if customers complain, and mind you, the number one complaint in CNC routers using vacuum tables, what we've heard, is parts holding. And when people can't hold parts, there's this knee jerk that, well, buy more vacuum pumps, buy a bigger pump, right? That's addressing the symptom and not the cause. So you've got all kinds of negative byproducts of that. Of course, you've got higher energy consumption. You've got more heat in your shop. You've got more noise, right? And so it's throwing more bad at trying to create something good. So what we've done with that particular product, and I'll get into it in a little bit, that's called tile gasketing. It's a huge game changer in the market. But when we look at production environments, and many of your your listeners are going to be familiar with creating custom fixtures. So if I were in manufacturing, I was creating one part all day, all the time, the best way of doing so is creating a custom fixture. Well, that's vacuum clamping. When you create a custom fixture, you're making it out of a non-porous material. You're sealing right on that plenum. You're creating a vacuum chamber. You're creating support structures to that vacuum chamber. Then you're routing a channel where you're going to lay the gasket in there and it has a vacuum port in it. And then you have your tool path, of course. So that's using that vacuum source to hold those parts down and creating that negative air pressure differential. So we certainly have products for both what's called inboard gasketing to create those dedicated fixtures, onboard gasketing, same sort of premise. Again, that pocket, that air chamber. Well, what we learned a few years ago is for our clients that are making projects where parts change all the time, the orientation, the geometry, even the material is going to change all the time, is the majority of the people using CNC manufacturing, especially in small business. So we developed a product known as tile gasket, and we saw that little snippet. And that's actually an earlier iteration. We've since released a version 2 of that product. But what we've done here is we've accomplished so many good things with holding parts on top of that spoil board. So we've used a peel and stick product. It's a gasketing material that has small perforations in it, 1/4-inch hole perforations. Now, the image that we were looking at before, that was our earlier version. That was our V1. And that is in a 12-inch by 6. It's kind of hard to, it doesn't really give it a good scale perspective, but that's a 12-inch by 16-inch square. Our latest version, which we're releasing now, our V2, is a 24 by 24, so quite a bit larger. But each one of those holes, each one of those perforations become a little vacuum chamber. That actually might be a sample product because there's a white stick underneath it. So maybe that's just a small sample piece, but nevertheless, we take these sheets and we cover the entire surface area of the spoil board. And we've accomplished a few things by doing this. Number one is we've covered 85% of the surface area of that drafty spoil board with this gasketing material. Inverse of that, therefore, we've concentrated 85% of the vacuum pull to those little holes. Now, the aha moment that people get is that we're not concentrating the pull of the vacuum. We're not concentrating all the air in the CFM through those holes. No. What we're trying to do is that gasketing material is sealing to the bottom of the surface area of your material, call it a sheet good. And each one of those little holes then become vacuum chambers for that to hold that medium, the material. So if we think back to the original thought process that the more that you cut, you're going to create all this draft and you're going to lose that efficiency. It's the opposite for us. No matter how much you're going to cut or how little you're going to cut, as long as we've got those vacuum chambers holding onto the parts, you're not going to lose vacuum hold or vacuum pressure. So this becomes a huge game changer. And we have oodles and oodles of videos and customer testimonials. And we have a YouTube channel that's filled with lots of video examples. But we can go from, and we use force meters. And we'll take a side-by-side comparison of a part. There's a video that I posted not too long ago, maybe a month or so ago. And we went out to our customer, a neighbor's shop, had a large 5x10 shop saver. And we used grid gasket underneath. And well, before we did that, we put a part up, a small part, maybe 4 inches wide, 12 inches long, something that would be easy to kick out, especially on the end as fulcrum. And it took 15 pounds of pressure using a digital force meter in order to move that. We put the grid gasket underneath to make that seal. We put the tile gasket on top using that same part in the same place, all zones open. I literally, and I mean literally, could not break that part free. My whole body weight was moving, and we got up to 90 pounds on that force meter, but it wouldn't break. So the hold strength, when you compare downdrafting to vacuum clamping and using this product, is astronomical. It's orders of magnitude greater. Now, what does this mean to process and the users? That you can spend, you've got this huge capital investment in your shop, and this is for your business. Your focus then is to get return on that investment. Well, we can spend tens of thousands, even hundreds of thousands of dollars on a CNC machine, but if you're not holding the parts, you're not being productive. You're not making money. You're not processing there effectively. So the focal point of the production of that machine is about parts holding. Now, what when I talked about earlier about don't make do, make better, now we have our clients are cutting parts, small parts, 3 by 3 inch parts, no tabs, single passes. But more importantly, we just came back from AWFS the week before last. And I proudly and humbly say that we were kind of the talk of the show. We had people lining up to talk to us. And I talked to clients, who bought right there at the show, and they were so happy to have a good solution with parts holding because they were stressed. They would get this project going for cabinets, and they would say that I would go and I'd have my hand on the stop button. I was waiting for a part to kick out. I was listening to the motor, and it was stressful to them. They can hit go and they can walk away, and they know it's going to be processed well and right. So, and that's kind of the beginning. The advantages precipitate up. You've got better tool health, longer tool health. You're not breaking tools or bits, spindle health, drives and motors when things aren't kicking out. So it's a win-win all the way around. And not to be too verbose here, but it comes down, what we did is we took a more pragmatic approach to this and said, well, how much money could we save a shop, or how much more profit could we ultimately help a shop with better parts holding? So working with about a half a dozen of our clients, we sat down in a roundtable discussion and said, let's map this out. Now, I will backtrack just a couple of paces and say that the tile gasket becomes your new spoil surface. The common question that we have, and I'm sure your listeners are asking this already, is, well, how long does it last? And the answer I say, and not to be trite about it, is that, well, it's up to you. And the reason I say that is that it's designed to be scored into, and it's designed to be cut and etched, but you can't be haphazard with your Z. If the more that you're careful with your Z, the more that you dial it in and you make a nice clean through cut, but you're just scoring the material, the longer it's going to last. So we have well-documented cases with 400, 500, even greater hundreds of hours worth of production work. So with that in mind, we did an ROI analysis with real shops, real customers of ours, and only at 300 production hours. And we went job by job by job, shop rate hours, waste, new material, new nesting. And if we did only 300 production hours with one set of tile gaskets, the only less than a $300 investment on a 4x8 yielded literally $10,000 in savings by the end of that tile gasket lifespan. So you can see how it's a real game changer what we're done, and we're proud of it. The product is patented. We're not just a Me Too product. There's nobody else in the industry that's providing this. Nobody else is doing what we're doing with vacuum clamping. So we're very proud of what we're doing and how we're able to help small businesses and shops not only be more profitable, of course, but to have that peace of mind, higher quality product and so on.
So a person, let's take a typical 4x8 machine, a person who wanted to pursue this and get into that. What would they, let's assume that they're using the gaskets for the plenum, and then they're also using the tile gaskets on the top of a 4x8 machine. What's that going to cost them out of pocket, roughly?
Oh, I would say less than $400 out the door. To send, depends on how many zones and the size of the gasket. If it's odd and custom, it's a really wide gasket, etc. But generally speaking, for less than $400, you're going to outfit a 4x8 table. It's going to last you, hundreds of production hours, and many of our clients, if not all of them, find return on that within their very first project. It's a game changer.
Yeah, I think mainly of somebody who's doing like a cabinet shop work where they're making kitchen cabinets or similar.
Yeah.
If a cabinet part comes loose, it's very expensive from a material standpoint because they're fairly large pieces. But having a good seal around and not having those parts that increases how many parts you can cut every year, how many cabinets you can make without having to, do random repairs, because half of the problem isn't that the part came loose. It's then having to go and create another G code just to make that one part to replace that one piece.
That's right.
Yeah.
That's right. It's very disruptive. It's very, very disruptive when parts move. Um, and yeah, it it's really great to hear people when they're using it for our first time. We've got some videos on our YouTube where you've got the first time users using it, and they're like, their minds are blown. It just makes us really happy with something like that. Yeah, it's quite satisfying.
Well, listen, Alex, this has been amazing. I want to be respectful of your time and all. And if somebody wants to hear more about your product and your company, or maybe get a consult for their particular work holding needs, how do they contact you?
Sure. Well, first of all, our website's a great resource. We've got all a lot of content that's up there, everything you'd want to know and more. And you can also purchase directly from the website, and that's allstarcnc.com. We have a Facebook page, we have an Instagram account, and we have a YouTube account. And the YouTube, I think, we have more videos there than we have on our website, but you'll be able to see the product in action firsthand and a side-by-side comparison. And then a good email address is info@allstarcnc.com. You're welcome to send any of your questions. We're happy to consult with you, talk to you about your project, and help you out. And then lastly, Bill, as I mentioned, we recently launched our version 2 of the tile gasket there, and that's even becoming greater work hold capacity. So that original photo that you showed there showed the holes in a perpendicular and parallel orientation. Well, need is the mother of invention, right? So as we get better and we're doing this, people that are in the cabinet business, and that's one of the greatest industries or applications that we support. Well, people that are making 90-degree cuts, having those holes right there wasn't optimal, because every cut path or tool path, I want to have a vacuum pocket as close to that tool path. So we reoriented all of the holes in an odd angle. It's like 38.375 degrees, and created some randomized holes in there. So we're going to have greater hole power, and we have a larger format. So be happy to work with anybody. We love doing what we do. It makes us very, very happy to help people, and that's what we're here for.
One more quick question. You said that there is a YouTube channel. What is the channel name, or do you?
Allstar CNC.
Allstar CNC.
Yeah, if you search Allstar CNC, you'll be able to find us. You'll see me up there along with my cohort, Mike. He's affectionately referred to as Coach Mike, because he loves coaching people. I think the man may have been conceived on a vacuum table on a CNC machine, because that's lives, eats, and breathes it. And yeah, we're here to help.
Now, I usually ask Mike asked a question that I didn't prepare you for, but I'm going to ask it anyway. If it was a perfect world, everything was working right, you had all the resources you need, all the time, all the money for a project, what would you work on right now?
In this industry or without this industry, or anywhere?
It's your world. Yeah.
Well, I am deeply passionate and concerned about ecology and saving our natural resources. If there is a way to apply our sciences, our knowledge, our understanding to help better the world in retaining our ecology and the beautiful environment that we live in, and living in a successful industry and life and quality of life, I would be putting my passions into that as well.
Fantastic. So we've been talking with our new friend Alex Palm from Allstar CNC. I hope you found this interesting and technically challenging, because it's quite a subject. And even if you don't have a vacuum table on your CNC router, there's so many other applications where you could use vacuum and your regular woodworking as well. So this is kind of fun, and I've enjoyed it. I've learned quite a bit. And I would like to thank you for your time, and I hope that folks find this interesting. That would be what would make me happy today.
Thank you very much, Bill. It's been an honor being on your show. Appreciate it.
Thank you. One special bonus that Alex and the folks at Allstar CNC were willing to do. They've got a special discount code for the listeners of this podcast, and it's if you go to cncroutertips.com/CNCRT10. It'll give you a link to a special code, which will get you a discount on Allstar CNC products. Or at checkout, you can use CNCRT10 in the checkout code as a discount code. Thanks, everyone. Have a great day.